of physics, electricity is one of the most important factors in this world. And electricity is one of the reasons why modern society has progressively so rapidly in a changed century. Electricity has the power of homes, buildings, and power so many devices that we need in this world. And without the physical electricity, then we won't be able to control our electricity, and so much death or injuries will be caused.
Your actions have consequences, Zach.
Now, charge is the physical property of matter that is caused to experience a force when placed on its electromagnetic field. There are two types of charges, positive and negative. Photons carry positive charges and electrons carry negative charges. When two of those charges are exactly repelled from each other, and when two charges are opposite, they need to attach to each other. This is phenomenal to demonstrate with magnets.
Check your registration.
Now, positive charges can bring up to a lot of energy, which can power a lot of devices with a single charge. A negative charge, which carries a less amount of energy, which can charge up a lot of things in a very slow way. When two charges are exact, they repel from each other, and when two charges are opposite, they attach to each other. This phenomenon can be demonstrated with magnets. Protons carry positive charges, and electrons can carry negative charges. Alright, now, in electricity physics, there is this term called electromagnetic field. It's a field that is defined as an electric force being charged per unit. The direction of this field is taken to be the direction of the force. As you can see here, this is the positive charge, and the positive charge is going directly to the negative charge. As you see, these two energies are being put together. And this is where the rest of the positive energy is going out, and this is where the rest of the negative energy is going out. The electric field is radially outward from a positive charge and radially towards a negative charge to the point. Now, without these two terms of positive and negative electric, then there will be a very confusing way and a very hard way of powering up things or charging things.
A force is an interaction between two objects that has the ability to change the motion of one or both of the objects. This goes for electric forces. As you can see here, when two charges are different, they attract each other. Yet if two objects are similar, they repel each other. That is an example of electric force. A conductor is a material that allows charges to flow easily throughout the material. An example of a conductor is copper. Copper is a very good conductor, so electricity flows through it like butter. Because of this, copper is used in many cables, such as twisted pair and coaxial cables. An insulator is a material that does not allow charges to flow easily through it. Examples of insulators include glass, rubber, silk, and plastic. Conservation of charge is the principle that the total electric charge in an isolated system never changes. The net quantity of electric charge, the amount of positive charge minus the amount of negative charge in the universe, is always conserved. This is similar to the laws of the conservation of energy and the conservation of matter, which cannot be created or destroyed. It is always changed or transferred somewhere else.
Oh, you're done.
Current is a flow of electric charge, usually electrons or electron-deficient atoms. A well-known example of current in action is lightning. Lightning is a phenomenon of electrons traveling from one point to another. Current is what powers all of our electrical devices, because if electricity didn't flow, then electricity wouldn't exist. Current is measured in amperes and can be measured by the equation I equals V over R, which is voltage divided by resistance.
Charging an object is the process of giving an object electrons or protons to emulate into natural charge. The two methods we are going to talk about are induction and conduction. Induction is a method used to charge an object without touching the object to any other object charge. Now, as you can see here, this generator is generating electricity or protons onto the phone charger. So the generator is processing or giving electricity to the phone. And without electricity, the phone will have a very negative and very useless, since without electricity, the phone won't work very well. Now you see, charging is also a really matter process which allows people to charge and even use other electronic devices. Batteries are a main important source to the environment because there are a lot of devices that run on batteries, like cars, TV remotes, phones, and all that stuff depends on electricity. Batteries are a small source that holds a lot of electricity. So batteries are made of three parts: an ion dot, which has a negative charge, a cathode, which has a positive charge, and the electrolyte. Batteries produce power through electric resources. When a battery is powering something up, it passes on the electricity, allowing that device to operate well. And if there is too much electricity in a battery, then it will explode due to the override. Now, as you guys can see here, there are a lot of sources of batteries. There is 4.5V, which holds a lot of electricity, battery D, battery C, AA, AAA, 4A, and A23. Batteries are a hugely important source to this world because without batteries, then those devices won't be powered up well. Now, this creates a current and powers the circuit as it's traveling through the devices. Now, batteries again are very important, which holds the source of electricity, but too much electricity in the battery will cause a circuit and will cause it to explode. So let's be very careful when you're using batteries with electricity.
Resistance is a measure of the opposition to current flow in an electrical circuit. Resistance is measured in ohms, which is the Greek symbol omega. All materials have some resistance, and depending on the amount of resistance a material has, it'll make either an conductor or an insulator. Resistance can be calculated by the equation voltage over current. Ohm's law is a law stating that the direct current flowing in the conductor is directly proportional to the potential difference between its ends. What I mean by this is that if voltage is divided by 2, then current is divided by 2. It is usually formulated as voltage equals to current times resistance. Electric power is the rate at which electrical energy is transferred by an electric circuit. The standard unit of power is a watt, which is 1 joule per second. There are several equations to find power. Voltage times current squared times resistance, and voltage squared divided by resistance.
So far,
Okay, so when it comes to electricity, there's this thing called Kirchhoff's law. Kirchhoff's law are these two set of laws that explain the flowing of electricity. The Kirchhoff laws are these two laws that are invented by a scientist, Gustav Kirchhoff. The first law, Kirchhoff's law, states that current flowing into a rod or a junction must be equal to the current flowing out of it. This is a consequence of charging conservation. And you see here at this diagram, you see the flow of electricity and see how they must be equal to E and F. Now, for the second law, which is the voltage law, states that the sum of all voltages carrying any closed loop in the circuit must be equal to 0. And you can see here, this is the voltage circuit, and you can see that this is all going to be going around the same area. And you can see all these equals to 0. Now, Kirchhoff's law are our best way to explain the flow of electricity, because without these laws, and won't be able to see where most of the flow of the electricity, which cause a lot of circuits and outbreaks. So Kirchhoff's law, Kirchhoff's first and second law of electricity. So a circuit is a path between two or more points, along with an electric current, and can be carried. There are many components in a circuit. However, the ones you need to know are switches and resistors. Resistors can be defined in several ways, either as a series, which two resistors can be next to each other on the same line, or as parallel, where two resistors are labeled in parallel. How do you solve the problem depends on the layout of the circuit. Now, to see this problem, we have an entire layer of circuits. Now, we're going to look at the problem and see how can we define these circuits as we go in the next couple of problems. Now, you see R1 and R2 are connected to each other, and R3 are connected to both of them. So you can tell that the R has very little resistance. Which shows that the circuits are gaining the same amount of electricity as they will continue in this path. While the R3 is taking most of the energy since it's going to be in this top. So as that electricity flows, you see here, that's where. So as that electricity continues to flow through this pattern, that shows that all the electricity is going to go down here and it's going to produce a less amount of electricity. Now, circuits are also very important as facts because without circuits, it also would function our electricity and depend on where the electricity going. So, as you can see, that circuits and ways on solving circuits are very important factors in solving systems when it comes to electricity. What up, physics? This right here is a small electric zapper, and this thing is very dangerous because it produces small amount of electricity. But like I said, the smallest amount of electricity can be dangerous as we don't learn to function it correctly. Now, I'm going to demonstrate this, how it passes on the electricity. We plug it in right here, and then we turn it up. Now, the more I turn this up, then the more electricity is going to pass on. Now, as I put it against certain objects, you can see the electricity being passed through. Now, warning, this is a very dangerous equipment, so be careful when using this. Now, the point of this demonstration is to show how electricity from certain objects like the outlet passes on to here and pass on to certain objects or living organisms. What we have right here is a small electric generator. This produces the smallest amount of electricity, the same amount of electricity that this is passing on to me. Now, the longer I put my hand on this, the longer I stay on here, then the more chance of a higher shock of electricity I pass on as I touch certain organisms or items. Now, as you can see here, the electricity is coming from the outlet and it's passing on to here, and the smallest amount of electricity is passing on to me. Now, as I step my hand off of this, but you won't be able to see the electricity because it's naked to the human eye. So, the more I put my hand on this, and the more electrons it's going to put onto me, and if I touch certain items or people, it's going to get some shocking news. Now, be careful when using this, because again, the smallest amount of electricity can be dangerous without the right use of physics. In the world of physics, electricity is one of the main factors in this world. Because without the world of physics, we won't be able to learn how to operate or even learn how to use electricity properly, because it's going to be very dangerous. And we need to learn how to control the electrons, neutrons, and protons properly, and try to make sure that we learn physics properly. Now, as the terms that we just discussed in this video, and the equipment that showed to you how important we need to learn the physics of electricity. Thank you for watching this video.